Have you ever really stopped and looked at your phone or your chair or even just your coffee mug and wondered, how did this actually get to me? Well, there's a hidden story there, one of creativity, engineering, and incredible logistics. And today, we're going to pull back that curtain. Yeah, it's a question we just don't think about much, right? But the answer, wow, it basically reveals the engine of our entire modern world. And it's not magic, not at all. It's a process, a complex, fascinating, and incredibly detailed one. So let's dive in and start to unravel this thing. I think the best way to picture it is as a giant modern maze. And to get through it, we have to navigate three key stages. First up, you got to learn the rules of design. Second, you need to build a smarter blueprint for actually making the thing. And third, you have to give every single product its own unique fingerprint so you can track its journey. All right, so our journey doesn't kick off on a noisy factory floor. Nope. It begins with that first, absolutely crucial step, learning the fundamental rules of design. This is the bedrock, the foundation for everything else that's going to follow. You know, it's really fascinating how modern design education approaches this. It's not just about sketching pretty pictures anymore, not by a long shot. It's this amazing fusion of creative principles on one side and hard science on the other. You know, understanding materials, physics, all that good stuff. The core philosophy they teach is something called iterative design. And you've got to forget that whole eureka moment thing you see in movies. Real design is, well, it's a loop. You build a prototype, you test it, you find out what's wrong with it, you figure out why it's wrong, and then you refine it. You just keep doing that over and over again until a product actually works for the people who are going to use it. And you know what? This process builds some seriously valuable skills way beyond just the technical stuff. It encourages creativity, a willingness to take risks and learn from failure, and the discipline to test ideas without bias. And honestly, those are the skills that separate a good idea from a great product. And you can really see this focus on hands-on application. I mean, the assessment for designers in training is split right down the middle. 50% is a written exam on the principles, sure, but the other 50% is a real, hands-on, iterative design project. It's just not enough to know the theory. You have to prove you can actually do it. So, what's the big takeaway from this first stage? It's simple, really. It is all about the user. A designer learns to think kind of like a detective, always asking, who is this for? Where will they use it? Can they afford it? Does it solve a real problem? That's what we call user-centered design, and it is the absolute heart of creating something people will actually want and need. Okay, so you've done it. You have a brilliant user-tested prototype. Fantastic. But now we hit the next part of the maze. How in the world do you make 1 million of them efficiently and economically? This is where you need a much smarter blueprint. See, the goals in a classroom are just totally different from the goals in a factory. A student just needs to create one innovative prototype to prove their concept works. But a factory needs to produce thousands, maybe millions of identical items that are economically viable and built with absolute razor-sharp precision. That's a huge leap. And the bridge between these two worlds, it actually has a name: Design for Manufacture and Assembly, or DFMA. This is basically a set of principles for designing products not just to work well, but to be built well. It's all about thinking like a factory worker right from the very beginning. To do that, you have to understand how things are actually made. And at its core, it really boils down to 3 main processes. You can subtract material, think cutting or drilling. You can add material together with things like welding or adhesives. Or you can deform a material into a new shape, like bending a piece of metal. Pretty much every physical product is just some combination of those 3 steps. And of course, the design choices you make are completely dependent on the scale of production. Are you making one custom bespoke suit, a batch of 500 ceramic mugs, or millions of smartphones using super efficient lean manufacturing? Each one of those scales requires a totally different blueprint to work. So the product is designed, it's been manufactured at scale, but the journey isn't over yet, not even close. Now it has to enter the global supply chain. So how does a company possibly keep track of millions of individual items scattered all across the planet? Well, the answer is data. It's all managed by incredibly powerful enterprise software. This stuff acts as the central nervous system of modern logistics, allowing a company to see and manage every single item, no matter where it is in the world. And the key technology that makes all of this possible is the concept of a serialized item. It sounds complex, but it's a simple and honestly revolutionary idea. You take a standard product and give one specific instance of it a unique lifetime serial number. It's kind of like a birth certificate and a passport all rolled into one. This leads to a fascinating question, though. These serial numbers, they aren't just a random jumble of digits. No way. They are carefully constructed codes, and they're packed with information. So how on earth does that work? Here's how. It uses a concept called a mask. A mask is essentially a template for building the serial number. Each little segment of the number means something very specific. Like in this example, one part might identify the factory. Another could be a code for the year of production, and so on. It's this incredibly dense packet of data, all disguised as a simple number. And this digital fingerprint follows the product everywhere. A serial number can be assigned on the factory floor, tracked as it moves through a warehouse, scanned during shipment, and even referenced years later for service and maintenance. It's the one single unbroken thread connecting the product's entire life. Okay, so let's bring it all together and take a look at the whole journey, from that initial classroom idea all the way to the customer. We've seen how a product is born, how it gets prepared for the real world, and how it's given a unique identity to navigate that global supply chain. This timeline really puts it all in perspective. It starts with the idea, shaped by those user-focused, iterative principles you learn. Then comes the build, where that idea gets translated into a real blueprint for mass production. And finally, the journey, where each individual item gets its unique serial number, its digital fingerprint, for a lifetime of tracking. And the key thing to remember here is that these three stages are not separate things. They're all deeply interconnected. The principles learned in the classroom directly inform the blueprints for manufacturing, and the whole shebang is managed by those digital fingerprints of modern logistics. And this isn't some abstract theory. I mean, look around you right now. Your mouse, your pen, the watch on your wrist. Every single man-made object has followed some version of this exact incredible path, from just a thought to a real physical thing. It's a complex, beautiful, and absolutely essential process that shapes the world we live in. So I guess the only question left to ask is, what part of it are you going to design next?